Okay, I went through all this work to show you that we got this expression. This part here that I'm circling with my mouse really goes for part B. We'll put that there in a moment. But to answer this question, what is the order of the reaction with respect to C, D, and E? You would have said this is first order, D is zero order, and E is second order. So you would have said overall then would be 3, because C is 1, D is 0, E is 2, 1 plus 2 is 3. Now going on to part B, we brought over the expression rate equals K, C to the first order, E to the second order. Remember, D is not present because D would be to the 0 order, and anything to the 0 power is a 1. So for part C, we're going to bring over that expression. I've already done there. I'm going to pick any one of my experiments. Okay, it doesn't matter which one, but any one of my experiments. And I'm going to, and for this one I believe I picked 2, yes. So I'm going to plug in the experimental data for experiment 2. Again, you could pick 1, 2, 3, 4, and 5. You should have nearly the same value of K. And I plugged in rate equals K, C, E squared. So here's my rate for experiment 2. I'm looking for K. I have my concentration for experiment 2 for C. I have concentration for E. Remember, D is not present. Let me get this out of the way. And then I need to square whatever concentration is I have for E. So here's the work going through. I did this times that times itself. So I took 0.2 times 0.2 squared, which got me 0.008. I divided 0.008 over to both sides, or I divided both sides by 0.008, and I got this value for K. Going on to part D, we're going to bring over this value of K, looking at the same expression, bring over our K. Remember, K is a rate constant. It stays the same unless you change conditions. So it's asking us to solve for the rate. So rate equals this. So I'm going to plug in my K from the other side. I'm going to plug in my concentrations given for D. And don't forget that C is first order, but E has to be squared. Okay, this math here is just bringing this number down, this number, and I squared this. So my unit squared and my units squared and my number squared. So 0.541 times 0.541 gives me this, moles squared, liters squared. And then I multiplied all these numbers and end up having 1.46 times 10 to the negative third moles over liters seconds for my final answer. Please submit all of example 9 now in Schoology. Thank you.